What we're talking about, remember, is where pollutants come from. We recognize that they come from human activity, namely the combustion of fossil fuels. And so what we've been looking at in the last segment was just, what exactly does that word combustion mean? And we looked at some examples of some combustion reactions and reminded ourselves as the importance of balancing those chemical reactions. Okay, so by now, you really should have, for sure, done that POGIL activity and done a little bit of practice with balancing these chemical reactions. And so here's a test for you. If somebody asked or told you this these words, could you write a chemical equation with state symbols? Now, the words are solid sodium plus liquid water react to yield hydrogen gas plus a solution of sodium hydroxide and heat. Write this chemical equation with state symbols. Okay, now state symbols I've not brought up to you before, but remember, matter can exist as a solid, liquid, or gas. When we say that's the state of the matter. So a state symbol, sometimes it's important to know, exactly what state your reactants or products are in. And so sometimes we'll use symbols. And the symbols we use are a lowercase g for gas, a little cursive L for liquid, and a lowercase s for solid, to indicate that those reactants and products are in those particular states. There's one more state, and we'll talk more about this particular state at the, actually not till next semester, but it's AQ, which stands for aqueous, which means it's dissolved in water. Okay, so given that information, why don't you try to, in your small groups, write out the answer for this one. And if you want to, you can turn off the video and give it a try before I actually write down the correct answer for you. Okay, solid sodium, you need to know that sodium is an element, and solid means, you can indicate it's solid with a little s next to it, the state symbol S, plus, that means it reacts with liquid water, that means water's in the liquid phase or state. To yield means, that's where you put the arrow, means gives, or that's the result of the reaction. Hydrogen gas, you have to remember that when you write hydrogen, it always exists, a diatomic molecule, so you have to write H2, not just H, and it's in the form of a gas, plus a solution of sodium hydroxide, and since this all happened in water, I know it's an aqueous solution, so that means my sodium, and you have to be able to write down sodium hydroxide, because you learned that polyatomic anion, the hydroxide anion, has a -1 charge. So to write it down, it's NaOH, and since it's dissolved, we're going to say aqueous, and heat. Sometimes in a chemical reaction, we will add if it takes heat to make it go or if heat's given off. All right, and so in that case, we just wrote down heat as a product because heat is given off in this particular case. All right, so once you correctly write down all of the parts, or excuse me, all of the components, the elements or the compounds, then you have to take a step back and look at it and ask yourself, does it follow the law of conservation of matter? That is it balanced? And so you just go through, and look, okay, sodium, one sodium, one sodium. If you want to, you can draw little circles if that helps you, the little spheres, if that helps you model it. If not, you can just recognize this. There's one sodium here and there's one sodium there. There's one oxygen here, there's one oxygen there. There's, on the left-hand side of the equation, there's a total of 1, 2 hydrogens. And over here, there's a total of 1, 2, 3. So everything is balanced here as written except for the hydrogens, so we're going to have to fix that. And so to fix that, I can look at my, if I have, let's see, I have 3 on this side. That's sort of a pain because it's an odd number. So the only thing I can do over here to get more hydrogens is to put a coefficient in front of the water because it's the only place where the hydrogen exists. So I'll start by just trying to put a 2 there. Start with the smallest whole number and just work your way up until you get things balanced. And in this case, that's called balancing by inspection. It's just sort of back and forth. I have 4 hydrogens here, and I have 3 over here now. But if I put a 2 in front of the sodium hydroxide, I can get myself up to 4 hydrogens. 1, 2, because there's, remember, 2 whole units of this. So there's 1, 2 hydrogens plus 2 hydrogens here. That's 4. And then there's two, molecules of this. That's a total of 4 hydrogens. So that's worked out nicely, but I've messed everything else up because I put a 2 in front of the sodium hydroxide. So to fix that now, I can go back and put a 2 in front of the sodium. Now that's balanced. And let me see, is everything else in order? I believe so, because the oxygen here, there was 2 now because of that coefficient. There's 2 there. 4, yes, everything is balanced. So that's an example of sort of what I'd like you to be able to do is balance that. Now for the sodium hydroxide, when you're balancing, remember you can always look at a periodic table. If you couldn't remember, hydroxide you just have to memorize that has a -1 charge. But for the sodium, remember you can find it on the periodic table, see that it's in group 1, and know that it's going to carry a +1 charge. And that helps you know how to write the formula for this ionic compound, sodium hydroxide. All right? Okay.